So here's our cyclohexane model again. I've put it in a chair conformation, the most stable conformation. You will note that the red ones are in the axial position. They go straight up or they go straight down. Straight up, and then the next one will be straight down. Straight up here, and straight down on the next carbon. Okay. Also, the other group is in the equatorial position. So here we have an equatorial, it's going out, think of equator maybe. The equatorial position goes out to the side. This one is going out and up, so it's equatorial up. The next one on the ring, as I turn it, is also equatorial. It's going out to the side, but it's equatorial down. Equatorial up. The next one then will be equatorial down. So they're going to alternate. Each position will have an up and a down, and each position will have an equatorial and an axial. Okay, so this one is axial up, equatorial down. This one is axial down, equatorial up. Drawing your chairs precisely is very important. I need to be able on exams to tell whether a substituent is axial or equatorial. So let's go over how to draw these. I'm going to give you two different ways, actually. Step one of this method is to draw a wide V, kind of a shallow V there. We want to have an angle going down about 60 degrees. Then the next line we draw is going to be parallel to this first line. Then we're going to parallel this, the next line is going to come from here. It's going to parallel this line. And then we connect the dots. Okay. The other way is to draw two lines that are parallel and a little offset from each other. Put a dot here and a dot here, kind of outside, and then we connect the dots. I don't really care which method you use, but you do need to be able to draw these figures accurately. Now let's put our positions on our figures. Let's start by putting the axial positions on. I think those are easier. Make sure when you do your axial positions that you make them straight up and down so that I'll know that they're not equatorial. There's one, up, down, up, down, up, down. And then we'll do the equatorial. We start with this one right here. The axial is up, and so the equatorial will need to be down. Here the axial is down, so the equatorial will be up. Remember, each position has an up and a down. Each position has an axial and an equatorial, and they need to alternate. So this one will need to be down. This one will be up. This one will be down. This one will be up. And they're all my positions. Monosubstituted cyclohexane. So here we have a monosubstituted cyclohexane. It's got an X right here. This is in the axial position because it goes straight up and down, and it's in the up because that's the up direction. When the ring flips, this is a ring flip is what this is. The substituted position is now equatorial, and it's still up. Okay, so when the ring flips, it changes from being axial to equatorial, but if it was up to start with, it'll be up after the ring flip. So let's draw some of these. Draw both chair conformations for the following compound. So I've already drawn out the two chairs with all the positions. The axial is in pink, and the equatorial positions are in blue. So for the beginning, we can put this hydroxy any place we want on any of these substances. So let's just pick one. I'm going to put it right here. In this position, it is axial and up. So over here, we need it to be equatorial and up. So we need to find a position that's equatorial and up, and any will do. I'm going to move it one down and put it right here, because that's equatorial and up. Make sure you can draw these figures with all the possible substitutes on it. Okay, so let's look at this next one. I'm going to fold this over. There we go. So we can use my drawing. Now we want to do this amine. Let's put the amine here. This is an equatorial and down position. So when the ring flips, we're going to want it to be axial and down. So we can put it right here. The pink are the axials. Okay? When comparing the stability of the chair conformations, we find that it's best to have big bulky groups in the equatorial position. In the diagram here, this large group X is shown in the axial position, and you can see it's interacting with the other things that are in an axial position. So if it's in the equatorial position, they're more out of the way.